So the idea is that if you have a figure, right, any figure, then we can actually make use of the function that is called g-input, right, and then you say how many points of the figure you want to extract. So g-input is going to give you the xy coordinates that you are marking, right?
Okay. So then if I place 1, it's gonna give me the first point.
Right, so you say, okay, x comma y of g-input. So enter, and then let's say if we go really, let's assume that this is x, right, and this is y. And then we need to really to get a really long value in x and a small value in y, no? So click on the image and then enter. And so you can see here that the long value in x, right, so 311, but even though we were in the top of the image, y is very small, 16.
Yeah.
Right, so we do again, we just run again the same, but now a very long distance in x, but a very long distance in y. Click enter, so you can see that actually 335, 334. Okay. Because I assume that this is a image of
400 by 400.
What's the name of the image? No?
I-field. The one you're seeing in black is I-field.
I-field. 351 by 351.
Okay, and it's
okay. So, which means that the 0, 0 of the image actually is here, in this corner. Right, so, but then now if we explore this function, facet centroids, and we plot, now with the plus W, I don't know if that's gonna work, but let's try. Right now we have white pluses. Right, so let's find out. You can actually click here. Let's find out what is this point, more or less. So this one is in x 198 and in y 55, right?
Okay.
So it's okay because it's a really low y. But the problem is that what you meant actually originally was not this point over here. You wanted actually in x 198, but in y you wanted to have it here, right, in 55. Do you know what I mean? So your y originally with respect to this
okay,
xy,
so it should be it's the same, but the y has to be from bottom to the top.
Right, so it's just that it's right, so that's the right number, so that plus should have been here, but since the figure is in the opposite, you need to invert either the figure, or you need to somehow invert the y-axis, right? Okay. So if it's 55, it means that actually that 55 is 300 or 295, right? Plus 55 is actually 350, right? So that's one way to fix it. So okay, so this is the first one, no? So it means that, but look at this. So I don't see another one with 198 and 55. No, I don't.
Should I see another one?
No, I don't think so. I think that's the only one. But you also see here a second problem. You assume that this is, I'm assuming that this is x and this is y, right? But actually, you see it in the picture in the opposite way around. Actually, x is here,
yes.
X is 2, and y
is the first one.
Maybe we can just go a little bit down, maybe here. So 185 and 70. It's just the next one, right? The second. And then we can go to the next one, 170, and then you can go to the next one, 192. So it's just following this line. So now, how to fix this? Okay, first I will just first I will
one thing you must know. What does it mean this kind of plotting when you say FP double dot?
It means that you plot at once right? So if you say, for instance, only 1, 1, right?
Okay.
1, 1. It means that you are going to plot only one value, which is that one.
The first one. The very first
one,
point.
right? Exactly. So let me just delete this. The first one.
Oh, but you don't know.
But then you want to plot. You don't want to plot only the first two, right? So 1, 2.2. So it does just creating a vector.
And it's 2, 1
2.
because I have two coordinates.
You see 1 to 2. It's just, or 1 to 5. It's going to plot the first 5 directions. So because FP is a vector, right?
All the stats of the center.
Right, and the FP has column 1 and column 2, and the first one represents the row from 1 to 2, and the row from 1 to 2.
Okay, now you're just saying plot me all the values you get.
And just with 1, 2 dots means all the values.
Yeah.
Right.
Okay.
But I will invert this just like the first test. I will just change 0 a little bit. I think this is not the originally intended file, but now it's working fine. I just inverted the channels, and then I fix it now. Is that okay?
Okay, and can you explain me why it works now? Because I would like to know. Like I will use it like that, but I would like to know.
First plot, when you do plotting, right? First you place X, and then you place Y. And so we assume here that the first column is X, and the second column is Y. Right?
Okay.
The first. Secondly, secondly, okay, so this is the one, right? But if I just create a new figure, right? And then I just do plotting of that. Let me see.
A figure of what?
It's just an empty figure. Okay, so hold on. Any figure. Let me see why it can see the.
Yeah, but you're not like the figure of like you're not plotting anything. You don't have any value.
No, I should because they are plus. They're whites. That's why I can't see them. Come on. There you have. Right. Now, it's very interesting because the way that these pluses or circles doesn't matter, right? So you can have actually also.
Yeah, I will Google how to change the.
You can have just red circles, right? Doesn't matter.
I will Google how to.
Okay. Anyway, so let's go for the pluses. I like more the red, the red pluses. It's very interesting because now let's see what's the first one, or maybe this one in the top is in X is 110 and in Y is 300. But let's go to the first one. This one I think is the first one. No, maybe this is the one that has the smallest Y. This is the one that has
the second small.
Maybe this one. This one is the one that has the smallest X, and they really. So this one. This point, X55 and Y 198. So it's there because X is here and Y is here, right? But in the other figure, in this one, not in this one, sorry.
When you change the channels, yeah, now it's appearing like that. But the first one, it was like completely.
That one is. Which one? Where is it?
I think it's this one.
This one? Yeah, it's that one.
It stays the same.
Okay, it stays the same.
It's when you change the channels.
When I change the channels. So that's how I fix it. Okay, that's how I fix it. Yeah, then when plotting the centroids, it doesn't matter
I don't see the sense that if I take the Y column first and the X second. No, if I take if what you're doing is taking Y first and then X and then it gives you the right plot.
No, X first and then Y when you do plot. Then actually it places in the right positioning.
That's why we
right. It places.
Oh no, this is Y.
No, this is X.
Okay.
This is X. The first column is always X. Because if you go to the function, right, the one that does region props, so you get the stats from it. So this is actually a function from MATLAB, region props.
Yeah, I was reading about it. And what I thought about is this one is just giving me the intensity level, right?
It's a threshold, yes. It's a threshold because
Yeah, one
because if you do the mesh of this, right, this one, yeah, okay. So you are thresholding, you are just letting pass right information that is just above 0.5 in the intensity.
I also wanted-
Right.
I
So-
also have a question about intensity. What happened? I mean,
So you see, above the intensity. So the information you have, but okay, but because the original one, actually the original one is, sorry, the original one is without that filtering technique. Right, this is the original one. Right, this is the original one. So you see, sorry. So you see, this is the original image. Actually, if you move a little bit the threshold, a little bit more down, you will find more facets.
I wanted to ask you that. How can I check which value will be beneficial?
That's a question we have had already for 5 years.
Okay.
And we did something called auto thresholding, and we went from 001 to 0.99, and we ran a for loop
Okay.
with 100 iterations, and then we compared the amount of facets that each threshold produced in those 100 iterations. And then we decided, okay, because of based on our experience, we think, okay, 50% threshold should be enough, because if you let pass too much information, right? So maybe not there, but we can do it here. Let's say you can just let pass too much information, which means let pass
Everything.
almost everything. Sorry, yeah, almost everything. So you can see that the amount of facets. Oh, sorry.
No, actually, it's
not-
the other way around.
I don't see so many facets. Maybe it's in the other way around. Ah, yeah, sorry, it's in the other way around.
Try 0.9. But it should be if I lower the value more. Because if I lower the value, what I feel, I know, what I read about is that if I place a value, what is looking for intensity levels, right?
Yeah. It's strange that it's not letting pass. It's letting pass everything. I just see the same values. It's a bit strange.
Yes.
And we should have. Let me see how is this computed again. So you have the maximum value. You do because you are doing normalization. So so you normalize it. So let me just plot. What is this, right?
Okay. Something I'm learning now. I can plot everything about the picture.
What do you mean everything about the picture?
Because I didn't know I could plot that function. The maths, like the one about the intensity one. So when it comes to the picture, I can actually plot every value I want, or to check every behavior I want.
Yeah. You can do a lot of plottings. You can change this function as much as you want. This is normalized with respect to the center, with respect to the max, because this value just tells you what is the max value of the rows and columns, right?
Yeah.
Which is really saturated. I mean, 2 to the power 16. It's 65,000. It means that the image is almost saturated. It means that when we took this image, we had maybe too much light, because it's almost clip, right? It's almost clip.
I need to read about. I need to read about how to know when it's saturated.
No, it's like this. So you have the original image, right? So you can see that here. It's because this is an outlier, right? So this is the facet that doesn't belong to the eye, but this is a facet that is in between two eyes. Right?
Between the two eyes.
It has a name, I don't recall it now. And this is actually creating a sort of a problem, because this one actually had a lot of reflection, and this is and then we normalized the image, right?
I wanted to take out that one And what I'm realizing now is that I wanted to crop it 400 by 400,
Yeah.
and I'm getting 300 by 350 by 350.
Yeah, where is the cropping function of yours?
So I'm taking image edge. Don't listen to me.
Okay. So then it's 400, right?
I was testing. Don't listen to me.
Okay. Anyway. So yeah, this is not working. So let's see, maybe 200.
No, but then you need to change here as well. When I'm finding the.
So you mean that you have to go here?
Yeah, because for cropping I need to specify like the boundaries of the plots, right?
It's a bit strange way to crop, but I need to find a different way to do cropping. We do cropping a lot in there, so you just can find out how to do cropping now.
Actually, I found this way of cropping, which matched the YouTube of cropping in the duplex.
But cropping is just.
But I want to find a way. Like, is there a way like I could find a position of the, like, for example, see the full picture, right?
Yes.
And I know I want to take out the fascia between the eyes. Is there a way that I can crop like for manually? Like I want to go and I want to take out manually, for example, just the eye, and then I crop.
Whatever you want to crop, right? So that's why you can use the G input, right? The G input, you take. Let's say so. Let's try to do it here. Let me see if I understand what you want.
Let's say we want to crop from that facet we took out.
Yeah, let's say that you want to crop only. Let's say this region somewhere here. This piece of.
I want to crop.
You want just to crop manually. You want to really select where to go. Okay, so. Okay, let me see. Let me see. Just I need to know the size of the image. It's called. The original one is called I, right? So x comma y. First we take the size of the image, and then we take 4 points. Alright, so we will take 4 points and we will call them Cx and a cropping factor y. Okay. And then G input 4, and then maybe not this one. Okay, so
shouldn't it be 2 points, comma 4 to give you like from.
1 second, hold on. Show I. Okay, now let's say that I want to take only, let's say, this from this corner.
Exactly.
Actually, I don't need 4, I just need 2. Now that I recall. Now, let's do it again. Right. Then let's say I just want to take maybe from here till here.
Yeah, where the information
click, right, 2 corners, right? First up and then down. Okay, then you have these 2 values, right?
Oh, then I just play that one with my crop function.
And then you just say.
Yeah, in my crop.
1 second, I will write it down for you. So we call it im crop it.
Okay.
It's gonna be what equal im and in next.
It's gonna be this point.
You go from 300, so you go from C
X
all the way to C. So you just wait 1 second. Okay, CX, because CX you need to go CX 1. So then CX 1 until CX 2, comma CY.
Okay.
The small
Okay.
one, right? 1 until CY 2. Sorry, yeah, 2. Maybe that's gonna work.
But isn't the okay.
There is. This is your image crop, only taking these corners, right? I just left the rest out. And now you go and say you want to get all the information from that,
crop.
right? And again, we want to plot only this to this. Oh, I need to.
You need to change the file also in.
I just need to say, hold on.
But do you have to do it manually? No.
Yeah,
right?
you manually. But once you have those values, actually, you can always use the same values.
Okay, but you manually click anywhere, and it will give you specifically the values that you.
Yeah.
Okay.
Or you do it manually, or you just do it.
No, I like it that way.
But it's good to do it always the same for all the pictures.
That's why I like it that way. So you have.
Now you have it here, right? The pluses on the top of the facets, and it's much better now because this outlayer here, which is very intense, is not affecting the rest.
Yeah,
of the image.
I wanted to take. I will take that one out.
Right. Look at this, much better. And now you can say. Now you can say, let's say, Voronoi.
I wanted to input the.
Voronoi.
No, you have to say like. I think it's like the vector that you want equal Voronoi. If I remember correctly about the function.
Okay, let me see. XY.
Or Vx, Vy equal Voronoi.
It doesn't really matter if you call it with or without. I mean, it's nice because then you will save some information.
Voronoi,
yeah,
XY. Find the.
But let me see. So let me see how does this font information from XY looks like. So you run that example, and then you can see that X is like a column vector. But what about saying that you have, sorry, a row vector? But what about you have column vectors? You may have.
No, because the one you have to make column is your input vector.
It works the same. It doesn't matter whether it's column or whether it's row. Right, so you have just but then you have to put a comma. Okay, you have to put a comma. Then it means that here is just all the information that you have in 1, comma, all the information that you have in 2.
Oh, you should give me that one, exactly.
I just have to do this only once. Then you have Voronoi. Now, fine.
Exactly.
So things, yeah, because you have a double facet there, right? So you can tackle that a little bit with, it's 0. So I'm just letting pass everything.
0.5.
Maybe that's better. Oh.
Yeah.
So still there. Okay, so now you need another technique, right?
Yeah, I need to take out.
It's called in region props, right? In region props, there is a digitalization happening somewhere. So it's happening, and I will tell you why. So, NM, right? So this is the digitalized image, right? So you're not sending NM. You can send NM, right? This is just the binarization version of the image that you have. And then
okay,
here,
wait, I didn't understand what NM.
Well, I will tell you. So, comma, NM, right?
Okay.
We can call it just I crop binarize. Locally hates this type of
Okay.
file names of mine, but it just makes me remember.
Yeah, I don't know what.
Right, so now I will just say. So this is the Voronoi, doesn't matter. Then I will make a new figure, and I will say in show this one, right? Oh, sorry, I made a mistake.
Shouldn't you specify that mm is that variable?
No, because I just take it from here. But I want to know what is happening with. I can just place a pause here to remember what is the meaning of nm in this function. Time. Right, so I stop here. So you have the nm function. So it's just a logical function, right? It's a logical function. So it's just zeros and ones.
Okay, so it's binary.
Whenever there is a 1, it means that there is a
facet.
There is a facet. Do you see? There is a region with ones here, right? Do you see?
Yeah.
Region with ones. It means that it let information pass. But then I want to plot that, right? So zeros are going to be blacks and ones are going to be whites.
Okay.
Right. So
don't we need to change the color then? That's why we were looking at like.
Let me just do one more time. Do you see? Okay, this is zeros and ones, right? Okay, and it's detecting facets because you have these two objects. These are just two ones. I mean, it's a region of ones. They are touching. It means that this is just 1, 0, 1. But this one is not touching, but it represents one facet, right?
Okay.
So what you need to do is something called dilation and erosion. Dilation means that this is going to get dilated, so you can expand more information such that they will touch, because they represent a facet. Or you can erase, right? Erode. So which means that you are going to use like the tip, a digital tip that is going to erase really small values, and you define what is a small with the tip. Okay. The erosion and dilation. And I mean, it's a problem that we already solved a lot of times, and I don't know why Docker is not using it here. And then I tend to think that here we should dilate a little bit, right? Because then these two...
Yeah, but I can introduce it to the facet code.
Right, so we will just introduce it here. So let me see. We can quickly introduce it here. Dilation and erosion. I mean, I have solved this so many times.
Yeah, look, I need to remember.
It's called deal arrow. No, it's called
we can Google it.
Arrow. Erosion. Dilation and erosion, right? So, okay, it explains you what we have to do. Dilation and erosion, morphological dilation, morphological erosion. And let me see, where can I find that structure in elements? Okay, so first I need to define the tool that I'm going to use, right? And that's with so-called structuring element. And first I need to define that. I need to define the tip of my eraser or my tip of my brush, right? That is going to expand the ink.
And this panel, okay.
Hi. Sorry? Mauricio. Now first we create the tool, copy paste in the text, the tool, like the structuring
it's just gonna
element
be
composition.
It's gonna be like a diamond for a man.
Yeah, we can use a square, a diamond, we can use a circle.
Oh, okay.
It just tells you it just place a shadow on the bits that you are going to attack, either to expand more or to dilate, or to erode those ones, right? But diamond is my favorite one. So far it works fine. Where is the deal?
With a 4 side is also good?
The what?
4. Because you're telling it take me 4 units. Like, make it...
Oh, yeah, so, yeah. And then the size, you can also go up and down. I just took... im dilate is called. And then, this is the right way. So you use that tool, right? And then you take NM, and then this is NM dilated, dilatada. And actually this is, and this one is the one that we are going to use to detect now the regions. We don't want to detect the regions of the one that is not dilated, right?
Okay, so NM means
Very,
I'm defining it as the one that I'm binarizing.
It's a bit strange, that word. Maybe we can call it thresholded I core image thresholded, right?
Okay, so it means my boundary, and that's why when I plot that one, it gives me just white and black because I'm plotting my boundaries. So
yes, threshold is the thresholded. So, and this is called just I, doesn't matter.
Okay.
Like this is I thresholded. You take I, and then you take I thresholded, and now you take I thresholded dilated, right? I thresholded now dilated. So the thresholded, I is thresholded, and now it's dilated.
Yep.
And now you get the properties.
Okay.
That's it.
So now when I'm going to plot, I check. Okay.
And then if I do this, let's see. Now you can see there are no double facets anymore. Right.
Okay, really helpful, Mauricio. I'm gonna try to play it now.